Given this surdical equation on the board, we are asked to find the value of x. I know this may look like something difficult or complicated, but I promise you it is very, very easy. Just hold on for a few seconds. You see how easy it is. So we proceed first of all by writing our solution, and we write out the surdical equation. We write it this way: x to the power of x root x raised to power x plus 1. Now this is equal to 4 from the surdical equation we are given. We are going to write this expression using surd theorems, the rules of surd, and we'll write it this way. We say that this is equal to x to the power of x raised to power x plus 1, and this raised to power 1 over x root x, and this is equal to 4. Why? Because when you have nth root of b, this is equal to what? B raised to power 1 over n. It is from this rule that we transform this to this. We proceed to opening this bracket, and from here we have, when we multiply through, we have x raised to power x to x plus 1. This is all over x root x. Now this thing means the x root of x, and this means the x root of x raised to power x plus 1. So this is equal to x raised to power, because this is x root and this is also x root, so they are common root, so we write it this way as 1. That is the x root of x to the power of x plus 1 over x, over x alone. So we write this to this way because when you have n root b over n root a, surd root tell us that this is equal to the nth root of b over a. This is the nth root, not n times square root. No, this is not n. No, this is not like square root. It is square root when n is equal to 2, right? So this is just the general case, nth root, not normal, not just square root. Square root is a special case of an nth root. So this one here we are talking of an nth root. So in this case here we are talking of the xth root. Is that clear? Okay, let's proceed further. And remember, this is still equal to 4. So this is equal to 4. So from what we solve down there, this is where we arrive at. So when we have this, we say that this is equal to 4. Now recall from the rule of indices, from the law of indices, we have that if we have x raised to power b over x raised to power a, since it is the same x, similar base, it will not be x raised to power b minus a. Yeah, this is what law of indices told us. Now if you look at this now, this x, remember this x here is raised to power 1, and this x here is raised to power x plus 1. So from the rule of indices now, we have that, from the rule of indices, we have that this is equal to x to the power of x root of x raised to power x plus 1. Then this one now will be what? Minus 1. Now this will take away this, so we are left with x raised to power of the x root of x to the power of x, and so that this is equal to 4. So from here the same rule, that you have the nth root of a equal to what? A raised to power 1 over n. This is something that apply here. That apply here. So this will give us x to the power of x raised to power x times 1 over x. Right. So this will now be equal to, when this x comes inside here, we have x to the power of x raised to power x over x. So this and this will go, or you can even cancel it from here. So when this goes, so that x to the power of x is equal to 4. So this thing means that a number x raised to another number that is equal to 4. So clearly from here we can see that x to the power of x is equal to you can see that x to the power of x is equal to 4. So if we write this number 4 here, so that it will look like this, we know that 4 is equal to 2 raised to the power of 2. So we have x to the power of x is equal to 2 to the power of 2. So this is an equation, and by comparison the powers are equal and these are also equal. So either of them, say that by comparison we say that x is equal to 2 and this is the final answer. So this 2 is the solution to this equation. So thank you very much.